All right, learners, buckle up. We're diving deep today
Deep, deep.
into the world of cloud security and architecture on AWS. And to do that, we've got a pretty diverse pile of sources.
Yeah,
We've got some YouTube workshops, some really in-depth articles, and even some, community insights sprinkled in there.
the good stuff.
Yeah, the good stuff. And we're going to extract the crucial knowledge without hopefully overwhelming you, right? That's the mission.
Absolutely.
So what kind of goodies are we looking at today?
Well, we've got this fantastic Cloud Security Alliance workshop that really lays out some solid architectural principles, those best practices that everybody's always talking about.
Right.
But we're also going very practical. We're going to look at how to use specific AWS services like RDS and Direct Connect to build secure and resilient architectures. You know, the real world stuff.
And it doesn't stop there, because we are going even deeper.
Oh, yeah.
We're going to talk about the idea of virtual patching, how to defend against those OWASP top 10 vulnerabilities, and especially in serverless environments. Ooh, that's a good one.
Yeah. And then, of course, those ever-important AWS services like Trusted Advisor and Guard Duty, that can just really give your security posture a boost.
Huge help.
Big time. And then, just to kind of round things out, we'll touch on the unique security considerations for containerized applications.
All right.
And even get a little sneak peek at this new Amazon Q Developer CLI. So, are you ready to synthesize all of these different perspectives?
I'm ready. Let's do it.
Okay, let's jump right in. I think it makes sense to start with those foundational cloud security architecture principles. The Cloud Security Alliance workshop really laid those out in a very thoughtful way. They talk about the Enterprise Architecture Working Group and all the effort they've put into defining some solid cloud security guidance. I can imagine it's quite a task, trying to wrangle all the complexities.
It's a huge task, and the speaker actually used a pretty memorable analogy. He called it a dumpster fire at one point, which I thought was pretty accurate, to be honest.
Yeah. The sheer volume of security considerations can feel overwhelming. So one of the key takeaways for me was that we need to move beyond just listing best practices and really focus on prioritization.
Right.
And contextual application. Every environment's different. What works for a large enterprise might not make sense for a small startup, for example.
Absolutely.
And even with these exhaustive lists, the speaker joked about his slides being overstuffed. You can still be left wondering, okay, but what does this actually mean for my situation?
Totally. It's like, okay, implement network security. Sounds great, but how do you actually do that in a complex cloud environment, right?
Right.
The speaker also emphasized the importance of really understanding those control boundaries, especially where your control ends and the cloud provider's begins.
Yes. That software and infrastructure as a service stack, you got to know where you fit in.
Yeah.
And it's important to recognize, for example, that we have very limited access to the hypervisor layer in AWS.
Right.
So our security efforts need to be focused on the layers we can manage. Operating systems, the applications, the network configurations.
Right.
We define those within our virtual private clouds.
Right. And it's interesting to see how the traditional security controls we were all used to are sort of evolving into these cloud equivalents. The workshop touched on that, this shift towards more API-driven and automated approaches.
Definitely.
You think about something like vulnerability spanning. It's not necessarily the same tools or processes that we were using in our on-premise data centers.
Exactly. And this naturally leads into the concept of security in code, which was another key point the speaker made. Now, whether you think terms like DevOps and DevSecOps are buzzwords or not, the underlying trend is very real.
Right.
Security needs to be baked into the entire development lifecycle,
Absolutely.
from infrastructure as code all the way to software-defined networking. We're not saying that traditional controls like firewalls and log analysis are going away.
Right.
They're still important. But this proactive, embedded approach is becoming essential.
So this concept of shifting towards identity policy for isolation and control that the workshop brings up, that feels like a really fundamental change in how we think about security in the cloud. Is this something that's still evolving, or are there really established best practices around it?
It is a fundamental shift, and while the core principles are there, the implementations, the best practices, they're constantly evolving as AWS rolls out more granular controls.
Right.
Think about it. In the old days, we relied so heavily on VLANs, subnets, those physical network devices to control traffic flow. Network segmentation is still important in AWS, right? We have VPCs and security groups. But the power of identity policy, especially when you're using IAM, adds a whole new dimension.
Okay.
So now, even if two resources are in the same subnet, you can use policies to dictate whether they can even talk to each other.
Got it.
It's not just about where the resource is on the network, it's about who the resource is and what it's allowed to do.
And that ties into leveraging the cloud provider's inherent isolation mechanisms, right?
Absolutely.
Like, the workshop really stresses that the AWS account itself is a significant isolation boundary.
It is. And using multiple AWS accounts strategically is a powerful way to compartmentalize different workloads, different environments.
Right.
That way, if there's a security incident, you can limit the blast radius.
Right.
And then you can use cross-account IAM roles to grant the necessary access between accounts.
Right. Makes sense.
So you still have that isolation, but you have that controlled access.
Right. So, wrapping up the section on the Cloud Security Alliance workshop, they also gave these crucial reminders about planning for failure, which, I feel like in cloud environments is even more important than it was on-prem.
Yeah, for sure. Cloud is dynamic, things change, and failures can happen.
Right.
And they talked about the importance of having feedback loops in your security design.
Uh-huh.
This isn't a set it and forget it kind of thing.
Not at all.
Continuous monitoring, logging, being able to detect and respond to security events, those are all essential. And that feedback loop allows you to learn from any incidents, identify weaknesses, and just keep getting better.
Absolutely. So that was a great framework, I think, that the Cloud Security Alliance provided for thinking about cloud security architecture. Now, I want to zoom in on a very specific but critical aspect of that architecture, and that's how we connect our on-premises world to AWS securely. And that brings us to Direct Connect, which that YouTube series explains so well. So for someone who's not familiar with it, what's the basic idea behind Direct Connect?
So Direct Connect, at its core, is about establishing a private, dedicated network connection from your on-premises data center or your office directly to the AWS network. So instead of your traffic traversing the public internet, it takes a more direct, predictable path.
Okay. And it uses that global AWS backbone network, right? Which is like this high-speed, low-latency network that connects all the different AWS regions. But the Direct Connect locations themselves, those aren't necessarily AWS-owned buildings, are they?
You're right. They're not. AWS actually partners with these network service providers.
Okay.
Companies like Equinix that have these networking hubs in cities around the world.
Yeah.
So these partner facilities are the Direct Connect locations.
I see.
And so you connect your on-premises network to the nearest location, and from there, boom, you're on the AWS backbone. You can access any AWS region.
Okay. So what are the big advantages of using Direct Connect? Like, why would somebody choose to do this instead of just using the existing internet connection? I mean, when do these benefits really become critical?
I think there are a few key benefits that really stand out. First, you get dedicated bandwidth.
Yeah.
So if you provision, say, a 1 gigabit per second direct connection, you're guaranteed that bandwidth.
Right.
Unlike internet connections, which, can be a bit variable depending on traffic and all sorts of things.
Absolutely.
Second, and this is a big one for a lot of organizations, your data transfer costs can be significantly lower compared to internet data transfer.
Yeah.
Especially if you're moving large volumes of data.
Makes sense.
And third, Direct Connect gives you access to both public AWS services like S3 and your private AWS resources within your virtual private clouds, your VPCs.
Okay.
So really, you think about Direct Connect when you have those consistent high-volume data transfer needs, or if you have strict latency requirements that the public internet just can't meet.
Okay. So the video also mentions these things called virtual interfaces, or VIFs. What are those all about?
So think of VIFs as logical tunnels over your physical Direct Connect line.
Got it.
You have different types of VIFs for different purposes. You have a public VIF, which you use for connecting to internet-bound AWS services.
Okay.
Then you have a private VIF for connecting to your internal VPCs.
Yeah.
And finally, you have a transit VIF, which acts like this central on-ramp for connecting multiple VPCs through something called a transit gateway.
Okay. So things start to get a little more complex when we start talking about connecting multiple VPCs and on-premises environments. That's when we get into the territory of Direct Connect gateways and transit gateways. The Advanced Direct Connect video really dives into this.
Yeah. What's the difference between these two, and how do they help us manage these more complex connectivity scenarios?
So a Direct Connect gateway is a globally available resource that allows you to connect multiple VPCs, even across different AWS regions, to your Direct Connect connection. It's a lot more scalable than attaching a private VIF directly to each individual VPC, which you would do through a virtual private gateway.
Okay.
Transit gateway, on the other hand, acts like a regional network transit hub. You can connect your VPCs and your Direct Connect gateway to a transit gateway to simplify your routing.
Okay. But there's a challenge that the video points out, right? This
Yeah.
issue of transitive routing. So if you connect multiple on-premises data centers to the same Direct Connect gateway, they can't directly talk to each other through that gateway.
Right.
And the same thing applies to VPCs connected via the Direct Connect gateway. Can you explain what transitive routing means in this context?
So essentially, transitive routing means that if network A can talk to network B and network B can talk to network C, then A can also automatically talk to C.
The Direct Connect gateway doesn't inherently provide this kind of middleman routing.
Okay.
So if you have, say, two of your corporate data centers connected to the same Direct Connect gateway, they can't directly exchange traffic. And it's the same with VPCs connected through that gateway.
I see. So if Direct Connect Gateway doesn't allow that direct communication between my different on-premises sites, what's the solution if we need that kind of connectivity?
Well, there are solutions, but they can get a bit complex. One approach the video mentions is to use transit gateway peering.
Okay.
So if you peer two transit gateways in different regions, you can enable communication between the VPCs that are connected to those gateways.
Okay.
And for connecting multiple on-premises data centers, you could potentially use two separate Direct Connect gateways. However, the video then introduces this newer feature called SiteLink, which is designed to address this very problem.
Okay. Tell me about SiteLink. How does that work?
So, SiteLink lets you enable direct data center to data center connectivity over the AWS network edge. The key requirement is that both of your Direct Connect connections need to be associated with the same Direct Connect gateway, and they need to have either a private or a transit VIF.
Okay.
What's really neat about SiteLink is that the traffic doesn't have to hairpin through an AWS region.
Okay.
It stays at the edge of the network, which makes it a much more efficient way to connect those geographically dispersed on-premises locations.
I see. So the first Direct Connect video ends by mentioning securing these connections.
Right.
Obviously a crucial consideration. What are some of the key things to think about there?
Well, first and foremost, you got to think about physical security at your connection points
Right.
in those Direct Connect locations. You're also going to be configuring routing, access control list, all of that good stuff. Encryption's another key consideration, although these sources didn't go into detail on that. And for your VPC connectivity, those underlying security mechanisms of VPCs, things like security groups and network ACLs, they still apply.
Okay.
And one of the tech snippets we have specifically asks about using AWS Network Firewall
Right.
for that multi-layered defense in your VPCs. It's a key service for controlling both inbound and outbound traffic.
So moving on, we have a good overview of AWS storage security from that YouTube video that compares EBS, S3, and EFS. And we also have some specific details on RDS encryption from that beginner's guide. Let's start with RDS. So what's the main purpose of RDS? What is it designed to do?
Okay, so AWS Relational Database Service, or an RDS, is this managed service that's designed to make it easier to set up, operate, and scale relational databases in the cloud.
Okay.
And it supports a bunch of popular database engines, like you've got SQL Server, Oracle, MySQL, PostgreSQL, MariaDB, and even Amazon's own Aurora. And it's generally used for what are called online transaction processing, or OLTP, workloads. So things like e-commerce transactions or application backends, where you have a lot of read and write operations happening.
Right. Makes sense. And the RDS Beginner's Guide specifically talks about multi-AZ deployments. What's the benefit of using a multi-AZ deployment for RDS?
So multi-AZ essentially creates a standby instance of your primary database in a different availability zone within the same AWS region.
Okay.
The key thing to remember here is that this is all about disaster recovery and high availability.
Okay.
It's not about improving performance. So if there's a failure with the primary instance or even just routine maintenance, AWS can automatically fail over to that standby instance.
Got it.
That minimizes downtime. I can tell you, I've been in situations where a database failure in a single availability zone took down a mission-critical application for hours. If we had implemented multi-AZ, that entire outage would have been prevented.
Oh, wow.
It really drives home the importance of planning for those failures.
So what about encrypting RDS instances? The guide mentions that as well.
Yes, so you can encrypt your RDS instances at rest using AWS Key Management Service, KMS. And the guide actually walks you through the process.
Okay.
If you didn't encrypt an instance when you created it, you actually need to create a snapshot of the database encrypt the snapshot, and then restore a new database instance from that encrypted snapshot.
Got it. So now let's contrast RDS with some of those other storage options that the AWS storage video breaks down. We've got EBS, S3, and EFS. So starting with EBS, Elastic Block Storage, what is that and when would you typically use it?
So EBS gives you block-level storage volumes that you attach to your EC2 instances. So it's kind of like a virtual hard drive.
Yeah.
And each EBS volume lives within a single availability zone.
Got it.
So typically you'd use EBS for things like your operating system boot volumes if you need to host databases that require that fast, consistent block-level access, or really any data that needs to be directly attached to a specific EC2 instance.
Okay, so how does that differ from S3 Simple Storage Service?
So S3 is object storage.
Okay.
Instead of blocks, your data is stored as individual objects in what are called buckets, and it's accessible over the internet via these APIs.
Got it.
So S3 is highly scalable, very durable, and it's used for all sorts of things, like storing static assets for websites, hosting data lakes for analytics, backups, really any data that needs to be accessible from anywhere.
Okay.
And unlike EBS, it's not directly attached to an EC2 instance.
Okay. So then we have EFS, Elastic File System.
Right.
The video describes this as a shared file system. What does that mean exactly?
So EFS gives you a fully managed, scalable file system that you can actually mount on multiple EC2 instances at the same time.
Okay.
So this is really helpful for applications that need that shared access to the same data.
Right.
Like, think about web servers in an auto-scaling group. They might all need access to the same website files.
Right.
Or maybe you have these media processing workflows where multiple instances need to work on the same files. EFS is great for that.
Okay. And the video also briefly mentions FSX for Windows.
When would you use that?
So FSX for Windows gives you a fully managed Microsoft Windows file system service. So if you've got Windows-based applications that need a native Windows file system, things like shared drives for your .NET applications, that's where FSX for Windows shines.
Okay, so the storage video gives some good examples, right? EBS for operating systems and databases, S3 for internet accessible data and backups,
Yeah.
and EFS for shared data. It also talks about encrypting data at rest across these different services.
Yeah, most of the AWS storage services support encryption at rest using KMS. And you can actually choose whether to use AWS managed keys or your own customer managed keys for more control.
Right.
And the video also gave a practical example, talking about offloading static files from a WordPress site to S3 using a plugin like WP Offload Media,
Right.
which can really boost the performance of your site and reduce the load on those web servers. So let's move on to serverless security best practices, which that AWS reInvent workshop covered in detail. They start with an overview of what serverless security really entails. And they mention the defense in depth approach, which we've talked about a little bit already. What's the key idea behind serverless security and this concept of defense in depth?
Okay, so with serverless, the main idea is that while AWS is managing a lot of that underlying infrastructure for you, you still have a significant amount of responsibility for security,
Okay.
especially when it comes to your application code and how you configure things.
Right.
And defense in depth means implementing multiple layers of security controls.
Yeah.
So that if one layer fails, you've got others in place to protect your application, kind of like those medieval castles with multiple walls.
Right. Got to have those layers. So the workshop also references the OWASP Serverless Top 10, which we mentioned earlier, and the Well-Architected Framework Security Pillar. Why are those so important for understanding serverless security?
So the OWASP Serverless Top 10, that's a list of those most common security risks that you're likely to encounter when building serverless applications.
All right.
Things like injection flaws, broken authentication, improper access control. It really helps you focus on the threats that are most relevant in this type of environment.
Okay.
The well-architected framework, and specifically the security pillar, that provides broader design principles and best practices for building secure and reliable applications on AWS in general.
Right.
But they also have a serverless lens, which offers specific guidance for, how to apply those principles to serverless architectures.
Okay.
And what's interesting is that the workshop points out that there's often overlap between these two.
Right.
Like, for example, addressing broken authentication. That aligns with implementing a strong identity foundation, which is one of the core principles of the well-architected framework.
Okay. So the workshop then breaks down serverless security into these four main categories: authentication and authorization, data encryption and integrity, managing application dependencies, and then, of course, monitoring and logging. Let's start with authentication and authorization in the context of API Gateway and Lambda. What are some of the best practices there?
All right, so for API Gateway, especially when we're talking about externally facing APIs, the workshop highlights the use of what are called custom authorizers.
Okay.
These are basically Lambda functions that you write to validate those incoming tokens,
Okay.
like JSON Web Tokens or JWTs.
Mm-hmm.
And then those custom authorizers return very granular IAM policies that determine exactly what API paths and methods that client is allowed to access.
Okay.
So you have a lot of control over who can do what. The workshop also mentions CORS configuration, which is super important for controlling which origins are allowed to make requests to your API.
Right.
And for Lambda functions themselves, you have to think about both the function policy, which defines who can invoke the function, like
Right.
API Gateway, for example, and the execution role, which defines what the Lambda function is allowed to do in AWS, like writing to a DynamoDB table, for instance.
Right.
And the principle of least privilege is super important here.
Absolutely.
You only want to grant the bare minimum permissions necessary.
Right. So what about data encryption and integrity, especially when we're talking about Lambda functions? They mention this thing called envelope encryption with the AWS encryption SDK. What is that all about?
Yeah, so Lambda functions, they have this temporary storage in the template directory. The workshop advises being cautious about storing sensitive data there because it's ephemeral.
Right.
It goes away when the function execution ends. But if you need to encrypt data client-side, either in Lambda or before it even gets to Lambda, you can use the AWS encryption SDK, which uses envelope encryption. So think of envelope encryption like this. You're sending a really valuable package, right? You put it in a box, you lock the box with a key,
Mm.
but you don't just send the key along with the package. You put the key in a separate, stronger envelope, and you encrypt that envelope with the master key.
I see.
So you only need to manage that one master key securely.
Makes sense.
And then the workshop also emphasizes safe serialization of data within your code and ensuring data integrity by managing your application dependencies and scanning them for known vulnerabilities. Tools like OWASP Dependency Check can help with that.
Now, monitoring and logging seem particularly crucial in serverless environments, right? You don't have those traditional servers to poke around in. So what are some of the best practices there?
You're right. Comprehensive monitoring and logging are essential. So you should be tracking key CloudWatch metrics, things like function duration, the number of invocations, and set alarms for unusual patterns. For API Gateway, you want to monitor stuff like error rates and latency.
Yeah.
And then you have CloudTrail, which gives you that audit trail of all AWS API calls in your account.
Right.
That's essential for security investigations. AWS Config helps you track configuration changes in compliance against your predefined rules. And if you need to trace those requests as they flow through your serverless application, you can use AWS X-Ray.
Okay.
But the workshop also makes a good point. You need to log extensively in all your components, but don't log sensitive data unnecessarily.
Right.
That just creates a bigger target.
Makes sense. So the workshop also talks about infrastructure protection for APIs, mentioning CloudFront, API gateway endpoints, and securing service-to-service calls.
Yeah, so for public-facing APIs, using CloudFront as a CDN offers a lot of benefits.
Mm-hmm.
You get DDoS protection via AWS Heal Standard, and you can use AWS WAF to filter out malicious requests at the edge before they even hit your API gateway.
Okay.
And the workshop actually recommends using regional API gateway endpoints when you're integrating with CloudFront.
For securing calls between your own microservices or even with external vendors or partners, they talk about mutual TLS or MTLS for authentication.
Right.
And for internal service-to-service communication, using private API gateway endpoints with VPC endpoints and resource policies can really enhance your security because you're keeping all that traffic within your own private network.
Okay. Let's move on to that article, Advanced AWS Security Architectures.
Okay.
They talk about this multi-VPC strategy where you create a separate security VPC. What's the rationale behind that?
So the idea is to create this dedicated security VPC that acts like a central hub for all your security monitoring and incident analysis.
Okay.
Your application VPCs, the ones where your actual workloads are running, would then send all their relevant security data, like logs and configuration information, to this central security VPC.
Okay.
So it gives you a consolidated view of your security posture across your entire AWS environment.
That makes sense. And the article also talks about the role of the master account and the subaccounts in a secure multi-account strategy. Right. So In a multi-account setup that's managed by AWS organizations, the master account is usually used for centralized billing and governance.
Okay.
And the article really recommends securing that master account very carefully,
Mm-hmm.
potentially even with non-AWS security measures.
Right.
Because if that master account is compromised, it can have huge implications for all your sub-accounts.
Makes sense.
And then for the individual sub-accounts where your workloads are, it suggests creating admin users with access keys,
Mm-hmm.
specifically for building out your infrastructure.
Okay.
And then you rotate those keys regularly.
Right.
That way, if one set of keys gets compromised, the damage is limited.
Absolutely. So the article then touches on using Session Manager for secure remote access and leveraging AWS security tools like Security Hub and config rules. What can you tell us about those?
Okay, so Session Manager, that's part of AWS Systems Manager.
Okay.
And it lets you securely access your EC2 instances without having to open up those inbound SSH or RDP ports.
Great.
So that improves your security posture right off the bat. And it also enables automated patching and allows you to execute commands securely.
Makes sense.
Security Hub, that's your central place to view and manage security alerts and compliance status from various AWS security services.
Okay.
And for centralized compliance and security monitoring, you've got AWS config rules, which let you define and enforce configuration policies across your entire AWS environment.
Okay. Now, the article, Best Practices for Running Containerized WordPress on AWS, I think this is really cool because it provides a very specific, practical example of how to secure a containerized application.
Yeah, it's a great case study.
It covers a lot, from compute to security.
Yeah.
So can you give us an overview of the architecture they present and the security measures they highlight?
Okay, so this article lays out an architecture that uses ECS for container orchestration, EFS for that shared file storage that we talked about, RDS Aurora Serverless for the database, Elasticache for Memcache for caching, and CloudFront as a CDN. And for security, they really stress encrypting all your stored data at rest using KMS-managed keys. They also talk about using AWS Certificate Manager to manage your SSL/TLS certificates.
Right.
And for protecting against those common web exploits, they recommend using AWS WEF on CloudFront.
Yeah, that's a key part of this architecture. What are some of the specific things they recommend doing with WEF?
So they suggest using several AWS managed rule groups in WEF, like the common rule set, known bad inputs rule set, and then specific ones for WordPress, PHP, SQL injection, and even one based on Amazon's IP reputation list.
Wow, okay.
It's a lot of acronyms.
It is.
But the idea is to get that broad protection against a wide range of threats.
Okay.
They also mention that you might need to exclude certain rules if they're blocking legitimate traffic to your WordPress app.
Makes sense. So the article also asks specifically about securing the WordPress admin page, WP admin.
Yeah.
What are some of the suggested methods for doing that?
They outline two main methods. The first is IP whitelisting, where you restrict access to WP admin to only specific IP addresses.
Okay.
The second is setting up a client VPN to access a private application load balancer, or ALB, that sits in front of your WordPress application.
Okay.
So that effectively limits access to the admin interface to users who are connected to the VPN.
Got it. And they also touch on protecting against some specific OWASP top 10 vulnerabilities like CSRF, SSRF, XSS, and injection attacks.
Yeah.
What are some of the key points they make there?
Okay, so for CSRF, which is cross-site request forgery, they mention using AWS WAF rules to check for those CSRF tokens and configuring S3 and CloudFront to use the same site cookie attribute.
Okay.
For SSRF, which is server-side request forgery, they recommend input validation and using the STS assume role API to limit the permissions of your applications.
Right.
For XSS, or cross-site scripting, they advise input validation and sanitization using HTTPS and leveraging those AWS WAF rules again. And for injection attacks like SQL injection, it's back to those WAF rules to block those malicious patterns.
Right. They also bring up this idea of virtual patching in the context of that log4j vulnerability that caused so much chaos a while back.
Yeah, that was a big one.
It was. So can you explain what virtual patching is and how it works?
Okay, so virtual patching is a technique used to mitigate the risk of exploiting a known vulnerability when you can't apply direct patch right away.
Okay.
So this could be in legacy systems or in third-party software where you don't have direct control over the patching process. Instead of modifying that vulnerable code itself, virtual patching is about implementing security controls, often at the network level, to block those known attack patterns.
Okay.
So you might use an intrusion prevention system, an IPS, or a web application firewall. And the idea is to prevent those malicious payloads from even reaching that vulnerable system.
Got it.
And the article mentions several IPS vendors that offer virtual patching capabilities.
Okay. Now let's talk about the threat detection and monitoring services that we have in our sources,
Mhm.
specifically Amazon Guard Duty and AWS Trusted Advisor. What do those do?
All right, so Amazon Guard Duty, that's a threat detection service that's continuously monitoring your AWS accounts and workloads for any signs of malicious activity. And it does this using machine learning, threat intelligence feeds, and anomaly detection. So it generates these security findings, which give you visibility into potential threats. And you can even integrate it with SIEM tools for further analysis and response.
Okay.
Now, AWS Trusted Advisor, that's a service that gives you recommendations to help you follow